an extension of beta and the associated function using generalized Mittag-Leffler function. Here is the outline of my presentation. Here is the abstract. In the present paper, we introduce a new extension of extended beta function using the Prabhakar generalized Mittag-Leffler function as a kernel. And also we investigate the various integral representations, certain properties, Malin transformation, and the functional relation, and further introduce the new extended Gauss hypergeometric function and extended confluent hypergeometric function by the new extension of by using the new extension of extended beta functions. Here are some keywords. Now the introduction. The beta and the gamma functions plays a very important role in the several application of a wide variety of physical and mathematical problems, especially in probability and statistics, in mathematical physics, also in economics and decision making. In decision making, the utility or economics utility function, the beta function is used to define the utility function. For instance, if a decision maker has a uncertain belief about the success of the investment, they might model this uncertainty using the beta distribution. Also in the game theory, its application in the game theory, particularly in modeling the expected utility of the players over the continuous strategies. Also in signal processing, beta function is used to define the window function and is used in the analysis of the signal and especially in designing the filter banks and the wavelets. Here are the definition, integral representation of beta and gamma function in equation 1.1 and 1.2. Both of these equations are defined for positive complex plane only. Equation number 1.3 and equation number 1.4 are defining the definition of Gauss hypergeometric function and confluent hypergeometric function. After that, here in these definitions, A, B, C are the complex number and C cannot be a non-negative integer, and AN represents the Pocamber symbol, which is given by gamma of A plus N over gamma of A. By using the generalized binomial theorem, we can find the integral representation of hypergeometric and the confluent hypergeometric function. For the reason mode of argument 1 minus z is less than pi. The study of the extension of the special function is began in 1990. For the first time, Chaudhary and Jubair give the extension of gamma and beta functions. Here's the question arises in anyone's mind that why the generalization, or we can say extensions, are really important to study. Here's the explanation for this question. The generalization of the well-known special function which extend the domain of the function and can be expected to useful to provide the important properties of the special functions are carried over the generalization in the natural and the simple manner. Of course, the original special function and its property must be recoverable as a particular case of the generalization. In 1994, Chaudhary and Jubair gave the first time the new extension of gamma function by using the regularizing factor exponential raised to power minus t minus p by t. Using this regularizing factor, both Jubair and Chaudhary extend the domain of the gamma function to the whole complex plane by reducing its singularity, which is occur due to when t is equals to 0. By reducing that problem, to solving that problem, they use this regularizing factor, and we can clearly see that for p is equals to 0, this extended new extension of gamma function can be reduced to its classical gamma function. In this sequence, Chaudhary come up with the next paper in 1997 and give the new extension, new generalization of beta function by using another regularizing factor, which regularizing factor is exponential raised to power minus p over t into 1 minus t uh, to extend the domain of the beta function. The important point to note here, the reason why these extension are so important, because before the classical gamma function cannot connect with many of a special or elementary function, but by giving its new extension, this extended function can connect or make a relation with many special functions like McDonald functions, error function, etc., many more. Uh, Before this, there is no relation between the original, or we can say classical gamma function and the beta function to the McDonald function. After giving the generalization only, we get these kind of connections between various functions. In the sequence, many other authors give a lot of uh, new generalization of beta and gamma function. In 2012, Ozergin gave the new extension of beta and gamma function using a confluent hypergeometric function. And in 2014, Choi gave the new extension using the exponential function only, but now this time he introduced additional parameter q. After that, Sadab presented the new extension of beta function using the Mittag-Leffler function, and where the Mittag-Leffler function is a generalization of exponential function. After that, Pucheta gave a new extension of Mittag-Leffler of extended beta function using Mittag-Leffler function, and after that, in 2020, Rahman extended the result of Sadab and define the extended beta function. After that, Ehtas in 2018 give another extension of beta and gamma function using two parametric Mittag-Leffler function, but this time they used a different argument. However, Al-Gohan and Muhammad utilized three parametric Mittag-Leffler function to introduce the modern new extension of gamma and beta function. As mentioned above, a number of authors have studied the various extension of beta and gamma function in the terms of integral whose kernel contains many type of special and elementary functions like confluent hypergeometric function, right function, exponential function, etc. In very recent year, the different extension of gamma and beta function in the term of the integral whose kernel contains the Mittag-Leffler function with different number of parameters. So motivated by these studies, we also introduce a new extension of gamma and beta function by using the three parametric Mittag-Leffler function. This Mittag-Leffler function is given by Prabhakar and is defined as below. Here is the new extension given by us of a beta function. These are some of the special cases. By defining taking the particular value to the alpha, beta, mu, nu, or p, we can obtain the previous result, those results which are studies or gained by the previous researchers. For example, if we take alpha, beta, and gamma is equal to 1, and mu and v is equals to 1 in our extended beta function, we can get the result given by Chaudhary, which referred in reference 1. After that, we studied some of the properties of extended beta function. This property, this theorem 3.1 gives the relation between the extended beta function and the original, or we can say classical beta function. After that, this theorem gives the different integral representation, we can get this representation by using the transformation, different transformation. We get this integral representation. By using this integral representation, we can study the asymptotic behavior of gamma function very easily. And the theorem 3.3 gives some important functional relation. And in the same way, the theorem 3.4 give another functional relation. In the same way, the theorem 3.5 and in theorem 3.6, we operate Mellin transformation over the extended beta function and observe the result. Using the extended beta function, we give the new extended hypergeometric and confluent hypergeometric functions definition. Here's the integral representation of extended hypergeometric and the confluent hypergeometric function. This is the integral representation of confluent hypergeometric function. Here's the application part where this beta or extended beta functions are applicable. First, in probability and statistic. Beta distribution. To define beta distribution, beta function is used. Beta function itself is a very used function in various fields. For example, in finance, helps to predict the uncertain outcomes and like how to stock might perform or the risk of involved in the investment. In biology, it helps to study the chances of the gene spreading in the population and the animals surviving in the different environments. And in many more like machine learning, engineering, operation research, psychology, in the short, it is great for modeling the uncertain events, especially when working with the percentage or probabilities. After that, in economics and decision, third one is in signal processing. After that, the main important application is in mathematical physics, in evaluating complex integral. In Feynman's diagram, in quantum field theory, the beta function helps to evaluate the integral associated with Feynman diagrams, which represent the interaction between the different particles. Special functions are used to give the solution to the different differential equations in physics. And after that, the important application is in conformal field theory. In conformal field theory, the beta function plays a role in scaling the behavior and the critical phenomena and helping describing the phase transition and the symmetry breaking. After that, in dimension regularizing. This is the conclusion. These results we obtained in this paper are expected to find the application in the significant research areas such as statistics, physics, engineering, and the applied mathematics. We are also trying to develop the computer algorithm for to compute these extended functions. These are the some of the references which are used in our study. Thank you so much.